And so we kind of have these sorted by the major subgenera. Over here we have Subgenus Rushla, which isn't very distinct, which contains the common Rushla medica, and although that's not an American species, that would be the subgenus that's within. We also have things like Albida, which is this beautiful, very pale colored Rushla. It's synonymous with Blanda, I believe. Another beautiful Rushla species in Subgenus Rushla is Flavida, which is yellow cap and usually a very stained yellow stem. And then one I haven't seen too many times is Ochroleucoides, which can be beautifully orange and pink when young, and then kind of as it ages, it gets more of these olive yellowish tones. The next subgenus is Malodora, which is kind of an oddball, and it contains Rushla compacta. And this one is also odd because unlike some of the fishy-smelling Rushlas, which we have here, but we unfortunately already put on the dryer, this one also smells like fish, but it's distantly related. And it's one of the easiest to identify with these brownish colors in the cap. It stains brown readily when you touch it, and it has a pretty foul odor. You're free to pass it around if you'd like to smell or come by later. The next subgenus that is interesting, and I actually find extremely interesting, is the Heterophilida, which is extremely diverse. You have things like Rushla variata, which you can see came in mass at this foray, and that's closely related to things like Crustosa, which can also be fairly easy to identify somewhat depending on the coloration, but it has this arylate or crust-like cap cuticle structure that kind of breaks into patches. And so these two are very closely related. But what's interesting is that you have other fungi like amenolins, which was here, right here, which is in the fetid Rushla group. And so it has very different odors, a very different look, but these are all still somewhat closely related, which is, again, highlights the morphological variability within Rushla, which has been one of the things that has made the taxonomic work so difficult. Another really cool member of the Heterophilida is Rushla cadaverolens, which smells like rotting flesh. And I've never seen this specimen before today. And if you're brave, take a smell of that as well. It does not smell good.
It's not quite as bad as a stinkhorn, but that's not great.
It's not good. And then the last subgenus that I'll talk about here is Rushla compacta, which is a little confusing because it doesn't contain the species Rushla compacta, but it contains a lot of the staining and blackening Rushlas in the Nigricanthes. This one here, which is, we called it the simulans, that might not quite be right, but we're just doing the best we can with the time we have here. And these are the staining, blackening. You can see it started out probably as a white mushroom, but from just being handled and drying, it's turned almost completely black. Any questions about Rushla before I move on to Lactarius?
The spherocyst cellular structure, does that exist beyond the genus?
It's definitely in all of the Rushlaceae. So all of Lactarius, Lactifluus, Rushla, and I think it's just the family, Rushlaceae.
What was the group of Rushla compacta that's not the Rushla compacta?
Yeah, so Rushla compacta is in the subgenus called Maldora, but then there's a subgenus compacta, which contains the blackening Rushla. And it's actually outlined very well. I'll highlight these cards.
Let me know if you guys can't hear, because I'll try to make the mic better, but
But he did an amazing job, and he actually defines all the subgenera Rushla on this card right here.
here's a table full of Lactarius. So that was Rushla over there, and these are Lactarius, which are milk caps. They are related to Rushlas, but they bleed a milky substance. These are a little dried out, but we have a ton of corrugated milk caps, Lactifluus corrugus, Lactifluus vulmus, Pex milk cap, Lactarius conferratus, all sorts of milk caps here. There are not very many waxy caps, but these are beautiful little colorful, waxy, wet, viscid mushrooms. And it's been a little bit dry. We haven't had a lot of rain, so that's what we got. They look like that. There's a bunch of claviloid, clubs and coral fungus over here. So we get all these things. There's a nice poster on them all. I'm just going to keep taking you guys around because the tour is happening, but they move kind of slowly and you guys have a short attention span. So here's our amanitas. There's a bunch of the destroying angel, Amanita bisporigera, and that one will unalive you if you eat it. So don't eat it or feed it to anyone else. But there's a bunch of other amanitas. Not all of them are poisonous. Some of them are edible. Here's a little poster on the amanitas. Amanita acea. Here's what we call a collection of little lights board. So what do we got here? There's Zemphrolina, Gymnopolis, Marasmius, all sorts of stuff. Here we have big spored mushrooms with white spores. So there's some oyster mushrooms. There's the odd Manzelia, whatever it is, Megacolybia rodmanii, a lot of that stuff. So here's all our big light spored mushrooms. We don't have that many pink spored, but that would be like Antilomas and Pluteus deer mushrooms, the Clitopilus prunulus, some Leptonia, subgenus Leptonia from Antiloma. So those are really cool, but again, they don't look super great right now. All of our Agaricaceae, the ink caps and allies, those are probably all melted, or just wasn't many of them. Here's a huge bag. This is like over 500 vouchered samples that we're going to go DNA sequence, so that's pretty cool. We broke the record for the number of observations this year at NAMA. Here's our what we call the dark spored horde. This is what Jacob and I have been working on, trying to figure out how to describe mushroom morphology. We've got, moving into polypores here. These are like the pore, what we call pore allies. So these are mushrooms that often have gills but have evolved from things that have pores. So, for example, here's a gilled bolete, Phylloporus. This is related to something that would have pores, like a bolete, but it re-evolved gills. So convergent evolution has created gills in a lot of things that didn't necessarily have gills originally, but now have gills. So this Coltricia, which is super like fuzzy and velvety on top, has these really cool looking kind of gill-like pores underneath. So that's pretty neat. And over here, we've got a bunch of other polypores that don't form shelves on wood necessarily. Think of like the Albatrellus, umbrella polypore, Berkeley's polypore. So there's some nice big chunks of Berkeley's polypore. You can confuse that with chicken woods if you're not careful. There's a beautiful piece of beefsteak fungus. This is always a crowd favorite of people. This one looks like raw beef when you slice it. It's pretty neat, but it's actually related to the Russellas where he first started out, and it has lots of little pores underneath. So polypores are all over the place. This is a really common one. It used to be Royoporus, now it's Pisciceps, I think. It's a black-footed polypore. You'll see these things all over the world, and they last forever. So let's see what else we got here. We have more crusts and stuff. It's kind of dry, so polypores weren't growing super well. This is the Niviofomes. Yeah, Nivioporofomes spraguei. That one. Sometimes they call it like the green cheese polypore, something like that. It's kind of cool. It smells weird. Some rosy conchs, other shelves. These are the big woody conchs over here. So we got like a nice big artist bracket, Ganoderma kind of thing. Lots of spores on top. Here's what is this? Oh, this is Fulvifomes. I thought this was a different one, but Phenphalinus. But this is a big woody conch kind of thing. I would call this kind of mushroom inedible. It's not toxic. You just can't eat it because it's wood, basically. You know, I get in arguments a lot with people over edibility. So here's the boletes, the boletales, blue staining boletes. This one grows in like Australia. I don't know why it's on here. We found a lot of this. Oreoboletus betula, Xanthoconium's pretty common. Telopolis, these like purpley mushrooms with small pores. Lots of Suillus. This parasitic bolete, we got some of that. It grows on scleroderma earth balls. But here's, a whole table of boletes. I think probably my favorites we were seeing are these Lanmoa. These are sort of a lookalike for the bicolor bolete, but they have an all yellow stem and they stain blue much more aggressively than the bicolors. Technically these are not toxic, so you can eat them, I think, but don't take my word on that. Do your own research. Here's Old Man of the Woods, pretty classic Strobylomyces. These are funny. They're edible, but I do not like the taste, so don't super recommend them. There's a little parasitic bolete that grows on scleroderma, so that's kind of cool. Technically, I have eaten these, but you want to be careful how many you eat because they do grow on a toxic mushroom. This is what's called the chromefoot bolete. This one's got hypomyces and mold all over it, but it's got this little yellow foot. When it's fresh, the stem is kind of blush pink and it's really pretty. We got a whole bunch of, what is this guy? Oh, this is what's called the ornate stalked bolete because it has this very ornate reticulated stipe. It's Retoboletus. The ones that have really yellow caps I've eaten and are edible. The ones that have like kind of more gray caps have been really bitter in my experience, but it's cool. These are pretty common, and there's a bunch of them. There's a ton of Swillus spraguei, the painted Swillus. This is actually a surprisingly tasty edible mushroom. If you guys ever want to try it, it's pretty easy to identify and it tastes good. It turns black when you cook it, so you might not think it's going to taste good, but then it is. It's pretty tasty. Okay, so we're going to turn and shift here, and you'll get to see this gaggle of people just looking at all these mushrooms that we kind of toured through. There's a lot of the heavy hitters of the fungal world in here. If you guys ever want to come to a mushroom camp, this is kind of what it looks like. It's a bunch of nerds looking at mushrooms. Over here we have what are being called the alien specimens, the zone of unknown. And this is just a silly way for them to take some things that we usually have a pretty good idea of what these actually are, but they're just like weird looking versions of specimens, mushrooms that formed strange because dry conditions or they were grown in a weird habitat, whatever it is. So it's, everything is in here. Most things are annotated. Anything that was super interesting we pulled out to go sequence, but all the other tables are organized by like the particular forays that people were on, and that's part of how they're tracking, where the mushrooms came from. For vouchering purposes, they have to know exactly where the mushroom was found and when and by whom, and we're accomplishing that by using iNaturalist to kind of set up all our observations. So here's another polypore, some pores on it, another like pinky polypore. So look at the underside. There's some more Swillus. There's some claviloid mushroom. Oh, here's a nice looking. This is Lactofluus corrugus. This one's not all dried out. It actually looks pretty good. This is a great edible mushroom. I cooked up a bunch of this weekend and fed it to people, and they really enjoyed it. And if you stay tuned, I made a lot of videos of this mushroom milking quite a bit. So you will see that on my feed at some point. We just have like tables on tables of mushrooms. There's Cassandra. She runs the San Diego Micro Club. Here's a chanterelle. It's, again, kind of dried out, but there it is. All this stuff looked a lot better like yesterday or the day before. It's just this is the last day of the fungus fair, and we're kind of doing one big overview before we pack it up. And all of these mushrooms, because people always get really concerned, like, we picked all these mushrooms, what are you doing with them? And like we took a lot of them to do DNA sequencing, for conservation, for understanding, and everything that isn't, getting used, we're going to throw back out in the woods. So in some ways, at this particular area, we're dumping tons and tons of spores and potentially increasing the fungal diversity around this lodge fairly significantly. And out in nature, our impacts are very small when we actually take mushrooms. There's so many mushrooms, there's so much mycelium. We've only gone to a couple little spots, and the biggest threats to mushrooms are not from human foragers. They are very much from climate change, from human development, from all sorts of stuff, but really not human mushroom foragers. So I see a ridiculous amount of pick shaming that happens, where people are, someone on the internet gets angry that someone else is doing something with a mushroom, and they're like, "That's not responsible." And you're like, "Hey, it's we're here to like conserve and pay tribute and understand these mushrooms." And sometimes you have to pick mushrooms to study them and look at them. We had Alan Rockefeller here who was doing a lot of microscopy. We had Stephen Russell here who's doing a tremendous amount of DNA sequencing. We have all these new tools to look at mushrooms in ways that we haven't had the ability to do before. And so, like I said earlier, this is actually, we collected and vouchered over 500 samples at this particular MICO event, and it's record-breaking for NAMA. So we're doing more and better science than we've ever been able to do before. There will may come a point where we don't need to pick so many mushrooms because we kind of know what's out there, but I think it's interesting, exciting for people to experience and touch and feel, look at mushrooms and really get a sense of them. So there's Mandy Quirk. She is in charge of the forays for NAMA. There's Stephen Russell, who's doing a lot of the sequencing. He's got his little dehydrator there, but these are like two absolute all-stars of the mushroom mycology world. It's funny to walk around in a room like this because people are pretty unassuming, but there are some major heavy hitters here that are just, there's a guy who published on all the different like hidden hedgehog species of North America, and he's like, a new paper with like 17 new species, and he's working on chanterelles now, and there's so many people here that are so knowledgeable. There's Ken from my club. He runs all of our events and stuff. There's this guy's in the Santa Cruz Fungus Federation. He's extremely knowledgeable and a really good mushroom hunter. We have some young people here too who've been like helping out with all of the sample collection and doing this kind of stuff. It takes a lot of legwork to get through this all, to label everything. So we have Ascomycete flask fungi here, and I think probably my favorite mushroom that I saw here is this Hypomyces luteovirens. So this is similar to a lobster mushroom, but it's a different species of Hypomyces that's kind of like weird, sickly yellow-green. Apparently it's edible. I tried it in Colorado like a week ago, but it's part of a mushroom medley, so didn't really taste it, but it's pretty cool. We have lots of other stuff, like these little Deldinia, cramp ball type things that grow on dead wood. I found a bunch of Ascomycete cup fungi, so I'm not sure why they're not on the table, but these are the other Ascos. They probably took most of them to sequence. This is a chunk of greenwood from Chlorosibaria. Here's some gastroid mushrooms. So these are mushrooms that like the spores form on the inside. So the big old thing of the scleroderma earth balls. We have a lot of these aspic puffballs, calostoma. These are just otherworldly looking, strange. I love them. Big old. Are these dieballs? What is this? So this is scleroderma too. It's a different kind of scleroderma. I've never seen that. But puffballs and bird's nest fungi. There's all sorts of stuff kind of included in the gastroid classification. It's not a genetic classification. It's just like a morphological. Here's plutoroids and allies. So there's some jack-o'-lanterns. These are toxic chanterelle lookalikes. Here's some oyster mushroom. You guys should recognize that. There's the Ruslos where we started out. I'm not going to try to capture the big glut of people, but that's where they are. All the work that was happening with sequencing and documenting was happening over here. We had microscopes set up. We had documentation things, all sorts of nerdy bit-by-bit things they were doing over here. So pretty cool to see all this. Let's see, can I turn this around? Nope, apparently I can't. Oh, there we go. Ha! Hi. I probably should have started with a face view. Good chance. Anyhow, it's been fun. This NAMA was a little bit better than the last one. In Missouri, it was pretty dry last year, but it is moist in North Carolina, so there's been a good amount of mushrooms, and learned a lot, saw some really cool people. This is kind of the scene. It's a mycology fest, so I would highly recommend you guys go check out some local mycology events, join a club, get involved. You can learn so much so quickly by being around some of these people that just know so much. incredibly inspiring and fun to be part of this community. So I'm going to sign off, but I wish you guys well. Have a good one. Much love.